seen a lot of you before, and I'm sure you're familiar. But again, we're using Zoom. Looks like most of you have your name displayed. That's really helpful for us to take attendance and mark any learning units. Just a reminder to keep yourself muted during when our instructors are talking, but we'll have times for questions and comments. So please feel free to chime in, and we'll also be fielding questions in the chat, and then provide the opportunity to share more about your question or clarify anything as well. Perfect. Next slide. Perfect. Keep it moving. Go to perfect. Might see a few more folks on the call today. I might be the only person from 3C Ren as well, but we have this great background that's Ojai, and feel free to ask me any questions too. You can chat me directly or feel free to speak up as well. I'm happy to help. Perfect. All right, so before we get started, who's 3C Ren, why are we here, and why are we bringing this course? So we're 3 counties working together to improve energy efficiency on the Central Coast. And we offer services for building professionals and households. So for professionals, we have training events, both technical and soft skill training, and energy code compliance support, courses like this, and then one-on-one support for more specific projects and questions. And for households, we offer discounted home upgrades to reduce energy use at home, and specifically for those who haven't been touched by previous programs in the area. Perfect, next slide. And 3C Ren is funded by ratepayer dollars that we all pay onto our utility bills. So some of those funds you can kind of see in the diagram go to the utilities and go back to the Public Utilities Commission. And then as a REN, we get to collect some of those and bring them back to invest in our local communities, to build our workforce here, creating some momentum for energy efficiency in the region, and supporting some of our state and local climate goals as well. Perfect. And just, simply put, we're working together. We want you to also be a part of this solution. We want to share the energy efficiency project with you all. So thank you for joining us today. And we can get started. Perfect.
Great. Thank you, Sean, for introducing us and getting us settled in here. Good morning, everybody. My name is Amy Dryden. As Sean mentioned, I'm with the Association for Energy Affordability, and here with Russell Bayba from Franklin Energy. We are super excited to talk with you about electrification in the 2019 code this morning. You guys all are on mute, but please, throw questions into the chat, as Sean mentioned. Feel free to raise your hand. We'll be going through this, and your questions, your experience is super valuable to kind of have that conversation and bring your on the ground experience, to the table. So with that, I think I'll get started. And you'll see Russell and I kind of passing stuff back and forth as we go through the presentation this morning. We will make sure we have time at the end for Q&A, but like I said, doing it throughout is kind of my preferred method. So what we're going to do is just overall, kind of our goal is understanding the electrification landscape, what's happening. I feel like it's been a very dynamic several years kind of advancing this. We're going to talk about common technologies and best practices for all electric design, and really talk about what's happening in the 2019 code and how is that addressing electrification, both for new and existing. And we'll touch a little bit on CalGreen, the Green Building Code as well. So this is how we're going to take you through this agenda. Really, again, kind of our framing is on electrification. So as we talk about pieces of the code, we're not discussing everything, right? It's a slice of it. So we'll talk about the landscape. Russell's going to take us through all the technologies and kind of what makes up this, idea of the electric home. Then we'll talk about the energy and the green building code. And then we'll close it out with some approaches for existing, as well as just a couple of case studies to start, to think about, show some examples of what we're seeing out there. And again, like I said, Q&A at the end, but really Q&A throughout. Like, raise your hand, share your experiences, and we'll try to ask some questions throughout to engage you. All right. So let me start right in on the landscape. And I start here. We can talk about, a number of things from electrification from early in the 50s when we had the kind of all electric home award, right, and all of this. But I start here just in the 1970s with the oil embargo, because that's where we started to think about efficiency and what does that mean because of energy independence. And that's where the Warren-Alquist Act of 74 started. And out of that came the Energy Commission and our energy code. So for those of you who've been building for a while, 1978 was our first energy code. And we'll look at kind of those stages, not that far back, but the stages as it gets updated over time, every 3 years, and kind of how it directs us in terms of continually improving our buildings over time. But it's with our goal of always kind of like reducing energy use, right? But as we start thinking about some of our shift and kind of what we're looking at today, I'll talk about that in a moment. We're looking at more than just energy reduction. With that, say kind of this idea is there's been more conversation on greenhouse gas emissions, right? Starting back with the 2006 AB 32, when we first established under Schwarzenegger, reducing our greenhouse gas emissions to 1990 levels. And so I put this up here just to kind of set the stage as we look at kind of what percentages from our buildings, so about 26, and we can see a large percentage of transportation, 37, and the rest is industry and agriculture. So our buildings are a significant opportunity, and this is what it means for us from a building standpoint, right? This side of the kind of circle donut pie on the left there is showing that, between the dark blue and the kind of light blue shows 67% of our gas use emissions from residential comes from space heating and water heating. And I call that out because that's where you'll see when we talk about some of the programs and kind of where the landscape is going, there's a big target towards space conditioning and water heating because it's such a large piece of our donut. I guess because it's not a pie, it's really a donut. And then to the right here, if we look at analysis done by E3, who's been doing incredible work for the past 10 years in terms of quantifying and showing kind of the impacts of addressing our building stock, you can see kind of if we look over the course of time, the years on the X 2020 to 2050, and we look at kind of our reductions from mixed fuel and the difference between all electric, which is all in green. This graph also is accounting for both natural gas combustion emissions as well as natural gas leakage, like within the distribution of itself. And so we can see as we move forward, we get significant reductions in our emissions over time. And so we can get 60% based on their analysis, emission reductions can be achieved by electrifying our buildings. So, and that kind of has been supporting this slew of legislation over the past 8 years that has really advanced a lot of this work on the regulatory side. So we've had legislation from SB 32 kind of building off our AB 32 global warming emissions, kind of setting 40% reductions by 2030. We've got clean energy goals by 2045. It's not too far away, and carbon neutrality. And we also have 40% reductions for existing buildings. The last one I'll just touch on the end isn't kind of a targeted goal, but it's State Bill SB 1477, and you may have heard of it, but it's the CPUC is directed to implement 2 statewide programs, one for new construction build and one for existing and new, really advancing the market for all electric or for low carbon space conditioning water heating. So all of this is in this response to adding a CO2 emissions to our work, rather than just straight energy savings as was approached like back when we had our 1978 energy code, and really trying to support demand responsiveness. So you can see this is how it's kind of shaping up in terms of our code cycles, right? 2013, we know we had new software. 2016, we added PV. 2019, we'll talk about PV required and storage. And I just put these markers in here, like, you know, around 2030, we're having clean energy, carbon neutrality up at 2045. We just got the 45-day language for 2022 energy code. So we're seeing kind of our code start to shift in this direction to really advance energy savings as well as clean energy or emission reductions. So the code is moving in this direction. State policy and regulatory side is also moving in this direction, but so are jurisdictions. And so I put this up here because we've got 42 jurisdictions across the state who have adopted some kind of REACH code that is preferring electric construction. Whether or not it's electric preferred, you can see kind of in this column here, or all the way up to electric, all electric required, on the far right. And there are several jurisdictions in the 3C Wren County, from San Luis Obispo to Ojai, and we've got Santa Barbara looking at opportunities. So we're seeing this kind of evolve, you know, kind of across the state. And so this is just some context for you of what you may be seeing in your area. So regulatory side of things and policy is moving in this direction. Jurisdictions are kind of moving in this direction to really achieve their local community goals as well as their climate goals. And then we're also seeing kind of funding to support this. So this is definitely a dynamic space that we're seeing, but I will say CCAs, community choice aggregators, municipal utilities, and IOUs all have these suite of incentives for like heat pump water heaters, central heat pump systems, space conditioning, as well as energy efficiency, right? We still want that kind of loading order of energy efficiency and then electrification, as well as PV and battery. And so there's existing incentives out there right now, and there's incentives that will be rolling out over time. An example of that I mentioned was the SB 1477 I mentioned a little bit ago. The tech program, that's low carbon water heating and space conditioning, maybe we'll roll out in April. That has incentives for equipment as well as training. And the build program, we'll see, maybe that will be towards the later portion of this year. It's really about new construction. And another plug for the self-generation investment program. It's been supporting PV and battery. And they're going through the process of adding heat pump water heaters as a thermal storage battery to that program as well. So again, there's a lot of thinking here and looking at how to support the market from incentives, from standards, and from training to kind of help us move us along. So all of this is to support heat pump technologies for all electric buildings. So now I'd like to turn it over to Russell to talk about what are those technologies, what do they look like, what are some considerations for them, and let him take it from here.
Okay, great. Thanks, Amy. My name is Russell Bayba. I am with Franklin Energy, and what we want to talk about here in this next section are technologies. We're going to look at things like, Amy, you can move forward one. We're going to look at electrification technologies, so heat pumps mainly, and then induction cooking. I always love this slide. It shows kind of the extent that heat pumps can go and what it can do. It's rather impressive. So we'll go look at the how efficient they are, but also how they work, the different types of heat pumps, air source, geothermal. We'll just touch on briefly. We'll look at HVAC, water heating, and closed drying heat pumps, and then also go into induction cooking. Okay, next slide. So how do they work? Essentially, heat pumps are just moving heat. So, in a house, they're moving in the summertime, they're moving heat from the inside of the house outside. And in the winter, they move heat from the outside in. They're just transferring energy between one place and the next. And this happens through a compressor and a refrigerant cycle. And I'm not going to go into a whole lot of detail about this, but it's a basic process, and it uses electricity. There's not a whole lot of energy transfer. It's a slow process generally, but it works a little bit longer than gas. Gas has a lot of energy in it, and heat pumps don't have that huge amount of firepower, but they move slowly and very effectively and extremely efficiently. The other thing is heat pumps are found all over the place, and the big one is in your refrigerator. So they're moving heat out of your refrigerator all day long. They're also in window AC units. They're in normal air conditioners, and so they're all around. So this is something we've been using quite a lot, and they extract heat in a certain direction, and you can change that direction with this expansion. There's a little valve that goes back and forth, and you can do one or the other, heat or cool. Okay, next slide. Okay, so I wanted to go into HVAC heat pump efficiency. I think it's good to get a sense of how efficient these products are. And the slide, the graphic on the right shows really how much more efficient these heat pumps are. They're more than twice as efficient as many of these gas appliances and even electric appliances are. They work in a wide range, but they're most efficient in temperatures above 32 degrees, and that's on outside generally. They work on basically two different ratings. One is SEER, which is for cooling. The other one is HSPF, and that's for heating. So they have different, you'll get two different numbers when you're looking at a heat pump, which provides heating and cooling. Typically it's SEER 14 through 18, but they can go up above SEER 30, which is very impressive. On the HSPF, the heating seasonal performance factor, it's typically about 8 to 10. So when you're looking at products, those are kind of the ranges you'll see. Certainly as it gets more expensive, actually as the efficiency goes up, it gets more expensive, but you also get a lot more bang for your buck in those more efficient products. They all generally are variable speed on the higher end products, and that helps with the efficiency. Okay, next slide. Oh, and I wanted to say in Vermont, they're getting heat pumps that go down below 13 degrees Fahrenheit, which is really impressive. Okay, so there are a few different types of heat pumps. Generally, what we see in most homes are air-to-air heat pumps. So they transfer heat from the air and extract and put it back into air, essentially. That's what most heat pumps you'll find do. That's what happens in your refrigerator and in your air conditioner as well. There are some that are transferring heat from the air into water, and those would be for water heaters. And there are some for space conditioning as well. There's a product out that produces hot water and cold water. And so you can use it for domestic hot water and for space conditioning as well. And then there's also geothermal. So This we're not going to go into much because it's expensive. There's not a lot of it out here. There's a few more places I think in the East Coast that use it a little bit more. It's a little more, seen there. And these are buried pipes in the ground essentially for the ground source, and they transfer heat from the ground, especially in the winter, right into the house, and then dump that hot air in the summertime into the ground. And a water source is a similar sort of thing. It moves heat through ponds generally. Okay. Next slide. There we go. So an HVAC heat pump, and I talked about this a little bit before, has a refrigerant line, and it is in the winter, it's extracting the heat from outside and dumping it on the inside. In the summer, it's doing the opposite. It's extracting the heat from inside the house and pulling it out. And it's moving heat from one place to another. It's a very simple process. And there's a refrigerant line that are insulated, they're copper, they're connected to the unit, in most cases, inside the house or in the attic, and then out to this compressor that's on the outside. As I said, there's a few of them where they transfers the heat from hot water or cold water and pipes it into the house separately, but there's not many of those. And again, this is something that can go down quite cold, and this, the graphic on the top here shows, snow on top of that heat pump. Okay, next slide. So now, one of the next kinds of heat pumps are mini splits. This has become, I think, more popular in the last few years, certainly in the US. They're very popular throughout the rest of the world. And here we're starting to pick up a little bit more. And one of the reasons is they're so efficient. They have much higher SEER ratings than central heat pumps, and they're also very versatile. They tend to be very small. They can have a single head like the one on the left here, or it can have multi-heads, and it have a small duct system. This is I don't know how many, whether there are 5 ducts coming off of it. I think it goes up to 9 heads for some mini splits. So it's you can do quite a bit with it. It's extremely versatile. They are pretty easy to install, but they tend to be a little bit costly. So they're more expensive to heat a whole home compared to like a central heat pump. Let's see. So yeah, so they have these cassettes, and this one is on the left here, bottom, is a cassette. There's different options. You can have heads in different places that they kind of allow you to essentially address each room's needs a little bit more specifically. They also have quite a bit more controls on them than central systems. Okay, next slide. So this is the central system, the central heat pump. This is typically what you would see on most homes. It's hard to tell the difference between this and just an air conditioner or a split system. They're ducted for the whole house generally. They work a little better in larger homes. They have higher capacity. They're integrated with the traditional ducting system. Zoning is a little bit more difficult on these compared to mini splits. And generally, these larger systems are cheaper than mini splits as well. I think we had a question here. Let's see. When we get to the end of this section, let's go through that.
Okay. I'll call them out when you're done.
Okay. I guess next slide. Okay, heat pump water heaters. I think one of the advantages of these is they're generally pretty simple. They install very simply. They're not a lot more complicated than a traditional water heater. They generally sit in the same sort of footprint. They do have, you're bound by the electrical line that's going to it, but the location could be fairly flexible. They're extremely efficient, and certainly a lot more efficient, 3 to 5 times more efficient than a tanked storage gas water heater. Generally, the sealed combustions are a little more efficient, but still these are very efficient. They're a little bit more expensive, but the price is coming down significantly. And to be more effective, it needs a larger storage tank. It doesn't recover as fast as a gas storage, and so you need a little larger tank to accommodate. Some considerations for these water heaters, heat pump water heaters, is they produce a lot of cold air. So they're great for an overheated garage or that kind of application. And so it's just a consideration of where you're going to dump that cold air. You also need, relatively warm temperatures around it. So you have to think about, you can't be in a closet that's sealed up completely. But if you have enough air circulation, that's fine as well. Okay, and let's see. Next slide. Okay, here's another thing that's pretty exciting to me is the heat pump dryers. They're starting to really pick up interest in the States. They work very similarly to, when they're a heat pump. So they essentially are heating up the air in the drum slightly, and they're circulating and doing this on and off cycle of basically heating a little bit of the air, circulating that around, and then bringing that back and dehumidifying it. So that warm, moist air is hitting the condenser and condensing and pulling that water out of the close, essentially, out of the air. And then it's repeating that cycle over and over and over again. And it slowly takes the heat out, takes the moisture out of the close. It's very delicate, and so it doesn't hurt the close. It's not having very high temperatures like in a gas dryer or electric. They tend to be a longer run times because it takes longer to do that. And some are actually, you can plug them into the wall with a 120 outlet, which is really nice. They're ventless, the other thing, and just you need a condensate line to drain that moisture out. Okay, next slide. Okay, and the other really exciting technology that's really starting to, I'm actually really excited about, and Amy and I both have a little stovetop induction cooktop. It's like a single burner to try this out. And so induction cooking is super exciting. I think it uses magnetic electromagnetism as a way to produce heat, and it produces a lot of heat very fast and can release that heat very fast as well. So on the top here, it shows, and I'd never seen this before, but the underside, basically under the glass. And so there's this heat treated glass on the range top, and then this sort of, I guess these coils underneath it. And it works through magnetism. So if you have a pot that you can stick a magnet on, it will work on an induction, which is an easy way to figure it out. I've gone through my pots and I've figured out which ones are induction ready and which aren't. Some of the advantages to this is they're very fast cook times. Let's see, I think let's see, it says one thing that's rather exciting is how fast it does it. So they've compared boiling 6 cups of water on the stove between gas, electric, and induction. And gas will do it in 8.5 minutes. Electric will do it in 5.5, and induction does it in 3. So it's very fast. It also goes up very high, over 600 degrees temperature, and then it also drops to about 100 degrees. And it does that very fast. So it's very responsive. You can dial in the temperature you want. And it's incredibly efficient as well. So the other advantage is that it's no byproducts. So there's no unburned gases, and there's less chances of burns because right around the surface of the pot that you're using is not hot. So it keeps it very cool. Okay, let's see, next slide. Photovoltaics and batteries. So this is really, we're trying to think about the whole picture when we think about PV and batteries. And this really rounds out what we need in creating an all-electric home. And this integration of creating energy, being able to store it, whether it's in the battery in the house or maybe it's in a car, and being able to supply energy to the whole house through this is kind of the whole all-electric home that we're really trying to think about here and how we're going to get there. Okay, next slide. Okay, so there's a lot of benefits to electrification. I'm pretty excited about how our world's going to change, and I think in a very positive way. I mean, there's climatic benefits, there's health benefits through reduced, better air inside, better air outside. There's a lot more resiliency that could happen. There's a huge amount of cost benefits over time. Especially when you're coupling solar, and the opportunities are beginning to rise about how to bring incentives into this and to get you going on it. There are definitely some things to consider. Just new technologies are difficult. They are difficult to overcome. I know as a builder in the past, anything new is always a liability at first, but I think as more and more people get used to it, it'll become second nature. And there's a lot of infrastructure that needs to happen. Electrical panel upgrades is a big one because there's a lot of electrical loads that are going to be introduced into homes, and generally our main panels are undersized, so that's certainly going to be a cost. And thinking about different rate structures too, certainly for electricity use. Amy, is there anything you would like to add to benefits and considerations?
I think you covered it. I think we'll talk about, some of the activities that are helping support some of the considerations in terms of the market and training and incentive. And we can dive into any of these deeper as folks have some questions. But what I thought I could do right now, Russell, is, well, first, I apologize, I forgot to do this at the beginning of the training, but if you all would be so accommodating to throw into the chat your name and your role. We have a pretty mixed group, and it would just be awesome just to get a sense of, for folks to know, like, oh, we've got a number of designers, we've got some jurisdictional, like building inspectors or plan reviewer professionals or contractors, manufacturers reps, like the whole suite. That would be really awesome. And while you guys are doing that, Russell, I can read you we've got a couple questions on what you've done.
Okay, great.
Awesome. Thanks, Spencer, for kicking it off in terms of getting your name in there. Okay. First question is the added, going back to the ducted systems when you were talking about the HVAC, heat pumps for HVAC, is the ducted systems, is the expense of the ducted units, is that due to the equipment itself or the installation or some combination? Because you had mentioned ducted versus ductless in terms of cost. Maybe you could expand on some of the considerations.
Yeah, so, you know, ducts are an expensive part of it because it's a manual process. So generally, if the ductless works, it keeps some of the costs down because you don't have to run ducts throughout the whole house in a new construction, from a new construction standpoint. And so mini splits tend to be a little less ducted, so that's a little cheaper. The initial cost of certainly of the units are more generally, but the operational costs are lower. So I'm not sure if that quite answers your question, but generally there's an expense around ducting that because it's a labor cost, that's a little higher for central systems.
Great. And I will say, sorry, I was just gonna say, if we're not kind of nailing your question and kind of getting it, and you want to raise your hand to say, wait, I would like to follow up, please raise your hand, or I may even call on you to follow up. So verbal engagement too.
And I think the next question was about condensing dryers.
Yes.
So that is an interesting one. What I found was that condensing dryers, the disadvantage is they use a fair amount of energy, but they also heat the clothes higher than certainly than not induction, a heat pump. But one of the things Amy pointed out to me the other day was that they also produce a lot of humidity inside the home because they tend to have these little trays that hold water that you dump out later. I think, is that right, Amy?
Mm-hmm. Yeah, and I was just going to add, sorry, I keep losing if I'm on mute or not. The other thing I would add, and this is where folks may be just trying to figure out, we have vented dryers and we have ventless dryers, right? So we're used to the electric or gas dryer that has the dryer vent, right? And that's going in the house, that's pretty typical. For the ventless dryers, there's two options, the condensing, which was put into the chat that Russell was just talking about, right? It's a condensing dryer, and there's a heat pump dryer that's also ventless. So just to keep those in mind, condensing and heat pump are not the same technology.
Yes, okay. Good point.
Last one question for you. Does the induction range only work with magnetic pots?
Yes, so sorry, I might have glossed over that too fast. Yes, they only work on magnetic, so they only work on steel. So they'll work on most, certainly all cast iron. There's many of the new pots out there are induction ready, so they have a steel component so that a magnet can stick to it. Generally, we're finding more and more that they're not making non-induction ready pots and pans.
Yeah, and you'll see, and I'm sorry we don't have it, but it's like a new icon for us in terms of if you're shopping for cookware. It's this kind of, to me, it almost actually looks like the symbol for insulation and plans. Not really it, but it's this kind of like coil image that's like, it shows that pots are induction ready or induction compatible, I should say. Cool.
That's good. I didn't know
that. Just one quick question. We've gone through a number of technologies. In the next section, we're going to talk about how the code treats it. But if folks could just raise their hand, how many of you have installed a heat pump water heater or heat pump space conditioning system? Just to get a sense of, or for the jurisdictional building inspection side, yes. Have you had to verify one? Okay, good. We've got 1, 2, 3 folks. Okay, awesome. 4. Great. So what I'll ask of you guys as we're kind of going through and we're talking about kind of the code and even talking about some of the applications of it, please raise your hand and share your experience or kind of considerations with them or challenges you've run into. So we've talked about some of the technologies. We've got folks who have hands-on experience with it in the area, and then we'll talk about how the code has done this. And then we talk about case studies, like let's hear what challenges people are running into or what not, or what things are really working well.
Amy, it looks like Bruce has raised his hand, maybe with
Cool.
a question or comment.
Great.
Bruce, you want to speak up?
Hi, Bruce.
Yeah. Hi. Thanks for letting me step in here for a moment. Bruce Severance, Mitsubishi Electric. I've worked as a contractor in the field as well and a system designer on energy upgrade programs for the last 10 years, and have some experience with heat pumps. I was going to ask if you guys were going to go into any of the detail of cost trade-offs and system optimization, so that you can go for these higher end systems without really incurring more cost. Are you going to get into that at all?
No, we weren't going to get into that at this point. I think probably more specifically that would happen on, a class on just heat pumps.
Okay,
I think
so your training program will get into that at some point?
I believe so, yeah.
Okay, I just wanted to see if that was within the context of this class at all, because I could probably give you my 90-second skinny on system optimization that I think would be helpful to this audience.
Well, let's see how we're doing on time, and maybe get you in the end there.
Okay.
That'd be great. Thank you.
Great.
Thanks, Bruce. All right.
And
Any other raised hands? Or I know I asked you to raise your hand if you have installed, but also just want to make sure we're not missing raised hands that are real questions or comments.
And Ruben also has a question in the chat as well.
Yep. What has been the reaction from the house building industry? Are developers embracing the idea of all electric homes? Seems like there are many cost savings, incentives, benefits, opportunities for selling the homes to a wider market. But what has been their response? That question. A couple of things I'll start with. The building industry is pretty diverse, right? Depending on kind of the scale of your building. But if we think about kind of like the larger scale builders and like the Building Industry Association, there has been support definitely in terms of moving and understanding where the code is going from an all electric stand, and supporting kind of PV in the 2019 code. There's definitely, I think, a balance in terms of, is there enough product in the market? Can we utilize this? So yes, support. There's been several larger developers who are kind of moving in that direction and have developments, on the coast to Sacramento that are all electric. I think with the requirement of PV in the 2019 code, that really kind of pushes their kind of cost into a much more favorable light in terms of going all electric. I think the general considerations that I think we're finding takes a bit of convincing across the board is really on the cooking side of things. There is concern of whether it's real or imagined, or real or perceived, or some combination of both. Kind of saleability, is that not even a word, saleability of homes with induction ranges. I think once folks experience it and understand it, there's definitely clear understanding of the benefits. And there's been a lot of work lately, a number of studies that have come out from UCLA, and then just a recent study from UCSF, collaboration with, I think it was Lawrence Berkeley National Labs, on the health impacts of combustion appliances in the home, and in particular gas stoves. So as we're kind of gaining more understanding of impacts and benefits, I think we're seeing the market shift a little bit. That said, there's a significant effort across the state to really advance the market. And I think that's coming from a couple of things. One, from training to make sure contractors kind of across the board are armed with the information, comfort, capacity to be able to deliver. We've got the product stocked in distribution centers, retailers, et cetera, so it's there. That consumers have the understanding of the performance of the equipment and the knowledge. So all of these things are moving forward. So it's a really long-winded answer. I think folks are definitely embracing it, but really kind of navigating those different conditions. I don't know if I did a really good job of answering your question, Ruben. Russell, do you want to add anything to that? You're on mute, right?
I think where we're seeing a little bit of definitely traction is certainly in the ADUs. There seems to be a lot more interest, or it's just a little easier to jump in an ADU. But yeah, I mean, I think it's a slow shift, but it's starting to happen, and I think the cost savings are really going to pull people over.
I think we're seeing, on the ADUs, right? It's a little bit easier because you're not having to, trench and run a gas line back to that unit. The cost savings that I think developers are realizing and seeing is, one, just the infrastructure reduction costs, right? I don't do trench or install that gas line like to the home or homes, and I don't have to distribute it throughout the house. The other is just kind of softer costs in terms of development, where I'm not trying to get approval from 2 utilities on the front end, which are not going to be in sync and various wait times. And I'm not trying to get green tags and approval on the back end from 2 different utilities. That is also a variable amount of time, and delays on both those times are staff, capacity and construction time can be delayed because of that, and also sale time. If I can't get that green tag and have it up for sale, those are also delays we're seeing. And Julie mentioned, just for folks in SLO, that you can borrow a single burner cooktop from the library. Awesome recommendation. There are a number of different places we've seen like doing these loaner library concepts, and it's a great way just to try it out, like see how it works. Russell's mentioned he and I are doing that because we're going to be replacing ours soon, our gas stove. But check it out, try it out, single burner, and see how it works. You can melt chocolate without doing a double burner. My kids love it because there's no flame, so they prefer to cook on that than our gas stove. Cool.
And I bought one also to loan out to people, so I loan it out to friends to try out, because they want to see what it's like, and they're thinking about it, but they just want to experience it. So I have a loaner as well that I use and lend out.
Awesome. There you go. You can help convert others, you guys. All right, let's go on to the code and talk about what's happening there. Okay, so mainly we're going to focus on the energy code, but I'm going to touch on the Cal Green, the green building code, just briefly for a measure you'll see. Most of you kind of are familiar with this, but I always just like to put it up just as we're kind of considering what are the measures or conditions that impact the scope of work that we're doing in terms of electrification. So again, narrow kind of slice of the code, only focus on electrification. There are some mandatory measures that are going to have to be hit, both for additions or alterations or new construction, regardless of what you do. What you may be seeing is folks taking the prescriptive path, really if they're doing like an HVAC change out, or water heater replacement, things like that, you'll see that prescriptive path, little limited flexibility, really for smaller scopes of work, maybe some additions, small additions. The performance path, where they're using compliance software to ensure that they are meeting the code, is 99.9% of our new construction falls in this category, and I would say most larger additions will too. Then kind of sandwiching that, like those are showing you the minimum code requirements, and then sandwiching that in some jurisdictions is the reach codes. So again, we can look at SLO, we can look at OHI, and some others as these are evolving, that maybe additional requirements that are need to be considered for complying with local requirements, local reach codes. I just put this up here just to give some sense of it, right? I showed you the 3-year code cycle, and really just to wrap our heads around it, right? It's addressing changes in standards, practices, and policy. They're always getting increasingly stringent over that period of time. And as I mentioned, you know, we're looking at this shift of not just straight energy savings, but emissions, and how do we really look at those reductions? I will say, that said, while we are at, you know, cleaner energy and trying to ensure that we have electric end uses that can be supplied by clean energy, the code is still looking at efficiency first. We're still maintaining that loading order to ensure that our homes are built as efficient as possible to reduce any of those overall loads. And that comes in a couple of different places. We're not going to go into all of these, but it's, and I can show you on the next slide, but I've got a couple here, like envelope measures, QII, indoor air quality measures. So the code's looking at that efficiency, right? Increased performance, more efficient mechanical systems, more compact distribution of hot water systems, right? To reduce any kind of structural waste. So we have that efficiency, and then the code is then adding on to it requirements for PV for low-rise residential. In our 2019 code, batteries are encouraged. For the first time, you can actually get compliance credit for battery storage or battery installation. And there's some requirements for that in terms of minimum capacity, as well as some controls in terms of time of use or basic control operation. And so what that gets us in our 2019 code is essentially a home, whether it's all electric or mixed fuel, has a minimum amount of PV to offset like average electrical use, which generally is going to be like a 2.5 kilowatt system per home if we look at a single family home. So that's kind of what our baseline is. And I put this up here just for those of you kind of thinking of like, what was 2016 and what's 2019 and how are things different? So efficiency, it's getting more efficient, 70 to 30%, depending on what your building type is and configuration, climate zone, et cetera, but getting more efficient. 2016, we had nothing to really support building electrification. It was a really challenging, it was challenging to get an all electric home to comply, even though the heat pump technology is significantly more efficient, right? Like Russell was saying, condensing gas water heater example is like 98% efficient, right? 0.98. If we look at heat pump water heaters, that example, they're like 3.24, so 300% efficient. Even with that variation, it was still very challenging. But under 2019, we've got a couple things happening. One is we have an all electric baseline for an all electric home. So all electric gets compared to all electric. That makes it so much easier. So even if folks are challenged, you know, and learning about technologies, the regulatory compliance barriers are kind of being removed, right? Which is very, very helpful. The other is if I install a propane or gas water heater under 2019 code, I must pre-wire for a heat pump water heater. So this is looking to think about how do we minimize capital costs in the future for retrofits, right? So we don't just lock in emissions today. EV, we've had EV for a while. And now under 2019, it's just more stringent, kind of closing some gaps on multifamily, but looking at kind of providing more infrastructure to all building types from single family to non-residential. And the solar is the big other thing. And I already touched on that. End of 2016, we had solar ready. That was fine. People thought about that. Okay, I can orient. I have solar, my solar space available, my solar zone. Now we have a minimum requirement of PV for low-rise residential. So again, covering these concepts, these are just kind of outlining those there. The other piece I'll just mention is the energy design rating. Now under 2019, we have two. One for just the efficiency of the home. Again, we're trying to make sure, yes, we have efficient homes, and then we layer on the PV and the storage onto that. And I'm going to touch on each of these in the next 3 slides. So this is just an illustration of that solar zone that was under kind of 2016. And now on the right side, you can see for residential only, we've got a requirement for PV. And it's really to offset like the standard electrical end uses of a mixed fuel building, which is really plug loads, lighting, and AC if it's in a cooling zone. So again, it's about 2.5 kilowatt system. And really, if you're going all electric, you're probably going to do more PV because it just makes sense, right? But the code is kind of hitting a minimum line. I mentioned the 2 EDRs. So this is just a reference for you all. This got introduced in the 2016 code, and here we are having, this is our 2016 standard code at 65. Now we're more, efficient for 2019. And then if we add PV onto our 2019 code, it's even lower there. So lower is better in this matrix, but this is a reference for you of how things are being handled. And last but not least, this is just calling out kind of the baselines. Again, a really critical component if you're doing energy consulting or architects and doing any modeling, where it was very challenging to get things to comply because of the baseline. And now it's equivalent. So electric's getting compared to electric, and you'll see much easier pathways for compliance under our 2019 code, again, which is a huge, huge barrier that's moved out of the way. We are still working on some of this for non-residential and high-rise multifamily. It's still a challenge there. The baseline is still mixed fuel. Okay. I'm not going to go into this. I put all this detail because you will see the slides after you kind of complete it. But just to call out that, I mentioned all homes that install, this is a mandatory measure for new construction, all homes that install a gas or propane water heater must pre-wire for a future heat pump water heater. And so it's got to have the 3 conductors, right? Because you want to be able to support 240. It's going to go from the panel to within 3 feet of the water heater. And it can just be a 120 volt, 20 amp receptacle right now. I don't have to activate all 3 conductors. So maybe I'm using it in the time being. So this is in addition to other manufacturers that have been in the code for a while for water heaters, but I want to call this one out specifically. In addition, or just maybe as kind of a quick side note, we are seeing heat pump water heaters that are coming into the market today due to a lot of work that are 15 amp 120. We also have 15 amp 240, 30 amp 240. They're getting a variety of products in the market, that can fit this. Okay. Oops. Those are some mandatory measures. What I want to talk about now is also just touch on some CalGreen, only for the EV side, just briefly, because 1, you're going to see this with any REACH codes, and 2, when we're thinking about electric and we're thinking about panel size and what's kind of going into a home, particularly for new construction, you're looking at EVs. And when we're thinking about existing and retrofits, people are looking for opportunities to charge at home. So just you can see we've got quantity based on 1 per dwelling unit. Multifamily is the percentage of total spaces, and same with commercial. Commercial, I put in there approximately 6% of the spaces, just because it's varied based on parking spaces. So on average, it's about 6%. All of them are capable. I'll show you what that means in the next slide. And all of them are level 2. So what is level 2 and what does capable mean? Here we go. Speed is there on the left, level 1, level 2, level 3. Level 1's my trickle charge 110, right? It can take a significant amount of time to charge. Level 2 is more the standard charging with 240. And level 3 is my DC fast charging, right? So that's how we think about potential for EVs. Then the readiness, the capable is what's required by code, which just means I have to have the conduit there, I have to have the capacity, but I'm not running wires or conductors. EV ready is I've got the outlet in there, I can actually utilize it. And then EV charging station is the full infrastructure. And then again, as you think about it for yourselves or for others, it's going to be the number of parking spaces. Okay. So that's kind of like new construction, right? New construction's got an all electric baseline. It's got some prereqs for mandatory measures for water heating, but what about additions and alterations? I'm going to go through this. We'll talk about this and we'll talk about some compliance. So alteration, just to clarify, is a change to the home, whether it's the envelope, the lighting, their HVAC. It doesn't add any condition, floor area or space, right? That would be an addition. And so those are treated differently. For the alterations, there may be some things that trigger the energy code, like replacing the HVAC, right? So if I'm changing out my wall furnace to a ductless mini split or something of that nature, or a ducted mini split, or if I'm changing out my gas storage water heater to a heat pump water heater, those are going to trigger requirements in the energy code. There's other ones for other measures in terms of efficiency that I listed here, but again, I'm not going into that detail. So all electric homes and additions can comply even when replacing natural gas appliances. Okay, so you can do that when you're doing an addition, it will still work. Additions are going to have to comply. They have a different standard in terms of size of addition. They are going to have to comply with efficiency requirements. They may pursue a prescriptive or performance pathway, right? Whether I do the compliance modeling like I showed you in that chart earlier. Alterations are going to be prescriptive, right? So again, it's that HVAC requirements for refrigerant charge or duct leakage. Those are kind of the two we're going to be seeing for alterations. And PV, although required in 2019 code for new construction, are not going to apply to additions. So if I think about heat pump water heaters for additions and alterations, here's my short slide that summarizes all those requirements for you. We have this ability. There have been challenges in the past in terms of replacing a gas storage water heater with an electric or heat pump water heater. The code really does not support electric resistance water heaters, but it does support heat pump water heaters, which are electric. So just keep those in mind. So depending on whether or not if I have gas or no gas available at the water heater, I have some different requirements. What I want to call out is the code here, and we've got a whole heat pump water heater class that goes into this in more detail. The code is really focusing on higher performing and incentivizing higher performing heat pump water heaters by referencing the NEA rated tier 3, the Northwest Energy Efficiency Alliance rating, which really looks at evaluating the performance of heat pump water heaters in terms of efficiency, in terms of decibel ratings, demand response, etc. If you don't use one of those higher performing ones, you have some other prescriptive measures to kind of balance out that efficiency, whether it's compact distribution or additional PV. So you can see those here, and it's by climate zone. So kind of the short of it, you can just go for a NEA rated tier 3 water heater, and it's that simple installation. For HVACs, for alterations and additions, right, you may be extending a system, an existing system to an alteration or to an addition, or you may be installing a brand new system, right? It really kind of depends on that scope of work. But just to call out, allowance for a heat pump, even if gas or propane is available, it's there. You can do it. You can add a new system, or you can replace an existing system, as well as extend it. You will have to meet like some of these prescriptive requirements. If I'm replacing enough of my existing system or installing a new system for that addition or alteration in terms of duct leakage, I'm going to have to meet those standards. It's going to have to be HERS verified and tested to make sure I hit that 6%. I also may be looking at refrigerant verification as well. So those are kind of like the big things I wanted to talk about in terms of what's in the existing energy code as well as green code in terms of electrification. And then briefly, I want to talk about some of the compliance documents. I'm only going to go through this briefly because 3C Ren offers a number of different courses that really dig into, a whole course solely on alterations or additions, right? And that compliance documentation to really make sure you've got it locked down. So this is kind of really this can kind of complement that or kind of build off of that, where folks can kind of follow on with additional training. But let's just kind of give this overview. Hopefully some of this is familiar to you all already. When we think about the compliance process and kind of like what documentations we may be creating as designers, architects, consultants, what we may be reviewing in terms of plan reviewers, we're thinking about this first section here. So I've got this kind of outlined by kind of construction process from plan review installation to third-party final inspection. And the first one we're going to see is CF1Rs. Those are like what is required by code. There's different form numbers depending on if it's new construction or an addition or alteration. They all start with CF1R with additional pieces after that. You'll see them submitted with the plans and specifications or an overcount of the permit, and they really show what's required to meet code. Please note that a CF1R is not required for an HVAC changeout to get the permit, but it's required to close it. Best practices require that at the permit when they're getting the permit because it's a lot easier than trying to wait till you close out. The second is for those of you who are contractors or installers out there, for a number of measures, you may be completing a 2R, which means it's like, hey, this is what was installed. I understand what was required by the 1R, and this is what was installed. And really, when we're thinking about electrification, this is really going to be focused on the mechanical, right? So that HVAC system I installed and the refrigerant and sealed ducts is what I'm going to be looking at for the installer. PV is only verified by the installer, so I'm going to look at that documentation. And plumbing, so those measures where I was looking at compact distribution or things of that nature. Those are kind of the three things from the installer side that we're going to be thinking about from documentation as it relates to electrification. A whole other slew of forms. On the third-party inspection, as a building inspector, you're going to be doing your standard inspection. I'll show you one slide on that. And you're going to be leveraging any of these install forms like the 2Rs, or you'll be leveraging a 3R form, that's the HERS rater form. So again, if I have a HERS rater verifying that refrigerant charge or the duct sealing, which they will, you can leverage that form and you can be like, okay, great, that's done. They met it. So again, mechanical and plumbing are going to be the ones that we're looking at as related to electrification. Again, there's a slew of other things. And so what does this look like? Again, a little flash in the pan of CF1R. If I'm looking at it, I may see on the front scope under general information, this is new construction. Okay, awesome. I know it's new construction. And then I'm going to look over here in terms of my heating unit type or my water heating type. I can see my heating element type and my tank type. So this is natural gas instantaneous. This one happens to be a central gas furnace. So if I'm looking for all electric construction, this is not it, right? Really simple way in terms of new construction and CF1Rs, this information calls out really clearly what you want to be looking for. If we think about kind of what's happening in the field, as building inspectors, there's a lot folks are looking for. And so I would just call out a couple of things. One, if it's all electric, you're going to say there's no gas meter there, right? The infrastructure does not exist. The other things I will just say, well, you've got a lot to look at. There's kind of key components that really kind of affect the efficiency of a home, from insulation to window types to the type of water heater and where it's located, as well as the HVAC. So those are things to look at to ensure that that home is built as intended and those benefits will be realized. Even as an architect or a contractor or designer, those may be things you want to double check too at the end of a project, right? Because you have multiple subs and you want to make sure, was it built as I intended? Am I going to see those results? So some of these kind of field verifications, while I was thinking about building inspectors, also really great practices for those of you who are the GC on a project to kind of look at that verification. So the next section we have is just a couple of kind of like approach and case studies that we can talk about. But before I go on to there, do we have any questions? Or are there any kind of questions or comments that folks want to share?
Yeah, there's one from Ruben. So if you have an all-electric home and can you have a gas meter and a gas line to supply grills and fireplaces and that kind of thing?
Yeah, great question. The energy code does not prohibit any of those. I will say also in REACH codes where jurisdiction, so the energy code is saying we are encouraging all electric homes or have an easy pathway for it, right? The REACH codes that jurisdictions are adopting are really saying like, oh, we only want all electric homes, or we're going to kind of favor them. In those REACH codes, many jurisdictions are calling out distinctions between outdoor gas fireplaces or grills or things of that nature, where they'll be defining it to say no gas infrastructure in the building. So then they're allowing kind of the infrastructure, for exterior uses. So we'll see that in the REACH code. The one thing I will say is I know people really like outdoor gas fireplaces and grills, and it will be time to get there. But what we'll see over time is like, just the cost. So still, that's a cost to put that in that gas line, and our rate structures are really going to affect the operations of those end uses over time. So that's just kind of a consideration in terms of what people want and what does it take, kind of responding to the market. But I guess the short answer is no, it doesn't prohibit it. Sorry. Not good on short answers.
Okay, we got another question from Alex. Are PV solar panels required by the 2019 code for all new residential structures?
Yes, so it's required for all new low-rise residential structures. So by the energy code, low-rise is defined as 3 habitable stories or less. So I could have a multifamily development over a parking garage, so 4 stories altogether, but that's considered low rise. All those into single family, all of those are required to have PV. And again, the code has sized it, so it's just covering a portion, like the electrical end uses based on a mixed fuel building. So it's about 2.5, like I said, 2.5 kilowatts. That's just my average per home. So and then I think, Spencer, did you have a question about PV that you want to ask out loud?
I just typed it in the chat to make it easy for you guys.
Okay.
It looks like Dan did have a question about PV though.
But there was one before me, yeah.
My question is based on what the size of the solar panel is based on, and you're saying it's that's a model home mixed use, right? If I'm going to go for an all electric home, is my PV going to be the required PV going to be based on me being an all electric home, or is it still based on the mixed fuel model?
Oh, good question. Thank you for clarifying that. It's based on the mixed fuel model. So what the code said, or what they wanted to do, is not require higher capital costs for all electric homes to say, oh, you must now offset X percentage of an all electric home. So the minimum requirement is based on the mixed fuel. So whether it's, let's just say the home I'm talking about, the mixed fuel, it's going to be required a 2.5 kilowatt system. And even if my proposed home is all electric, it's still going to be a 2.5 kilowatt system. That said, I think what we will see is the economics for the developer is to install a larger system size on all electric, but that will be voluntary. Does that answer your question, Dan?
Yes, thank you.
Awesome. And then Spencer, let's see.
Well, and Tom too, there was a question. I didn't quite understand it. What do you think of the third-party solar installers like Sunrun?
Yeah, that might not apply here, but these are the folks who come in and retrofit existing homes with solar panels, but then they own the system, so it's kind of almost like an easement on your rooftop. I was just wondering what you think of that.
I'm going to hold off on that one, but you're right. There are these kind of PPA models versus owner models where you're kind of, they're kind of renting your roof space. And so there's different economic models there. But I'm gonna punt on that for now, Tom, just to get through these other ones and some other slides, and maybe we can kind of come back to that. But I think it's an important thing. I guess I will say what's important for folks to know on existing is to really understand what the offer is from the solar provider. And so they're really clear on what they're getting. I think that would be my kind of like key takeaway without kind of going into an evaluation.
Thank you.
Yes.
And Ruben
Okay.
asks, let's see, Ruben asks if there's no indoor fireplaces in an electric home. I believe that's correct. No indoor fireplaces.
Unless it's electric fireplace.
That's true.
And then we cannot have, I guess I will also say there are some, again, it's on the reach code side of things where people are saying, you know, where jurisdictions saying must be all electric. And there are some exceptions within the reach codes where jurisdictions are saying all electric, and we will allow cooking or fireplaces to be natural gas or I should say non-electric fuel. So when we're talking about requirements for all electric, we're really looking at jurisdictions who are layering on their the reach code, which is their capacity to create more stringent requirements than our building code. We can't have wood burning fireplaces at all, and that's within our building code. But our building code does allow kind of sealed combustion gas fireplaces, pellet stoves. Again, on the reach code side, it's going to vary. Where can additional resources be found for staff looking to build technical capacity on part 6 and 11? So I think a couple of things. 3C Ren they've got kind of 2 tracks of training. One is kind of directed more toward design community, the building performance training, where you can understand a lot about building science. And then there's a whole suite of training under the Energy Codes Connect program, where we've got training on, you know, updates to 2019 code. What does that look like? Alterations or additions, or quality installation. So we've got a number of trainings. We, meaning the broader 3C Ren, they've got a whole bench of trainers who have different areas of expertise to deliver that. So keep an eye out there. I'm sure you know, you could always request things if you don't see something of like, oh, this is valuable. What is required reading for city staff working on a reach code? There's a number of different resources in terms of looking at the development of a reach code. I would say localenergycodes.com.
Yeah, it's .com. Yeah. I probably should have clarified that better. I'm working with Misty and Bo White on the statewide team, so we're a year out from even going through the, beginning the actual formal process. We're working on our climate plan right now. So, as a city staff member, I'm part of a team that's working on development of our energy strategies for meeting our climate reduction targets, right, that we're in the process of developing. So it's kind of, the question is more basic and where in terms of the Cal Green codes, where can we develop an understanding of that baseline off of which reach codes are based, right?
Yep.
So other than trainings like this, of course, it just, is there required reading or white papers or things that, my staff and I can kind of, build technical capacity off of, right?
Let me think about that a little bit more, because in addition to trainings, 3C Ren is offering, and of course, just reading the code itself, which is always fun. Which we do. There may be, let me think about that. The one other kind of potential, and this is not necessarily understanding the baseline, but also looking at the 2022 45-day language also gives you a sense of where the 2022 code is. And that can also offer options for reach codes. But let me think about some more additional resources.
Yeah, mainly if I were a new staff member and I wanted to learn about the 2019 codes and what they are, where would I start? Right, that kind of stuff. They're just very fundamental.
Yeah. One thing I guess I would suggest, sorry, Spencer, for interrupting.
No, go ahead.
On Energy Code ACE, there is a great resource. I could even hold it up if I knew where it was in my little pile. It's kind of a summary of the changes in the 2019 code. And it's written out with all the, based on the structure of the code sections, and it calls out what was a minor modification, what is new.
Great.
And I think that's a really good kind of summary, because now our code books are like, if we stack them up on the desk, they're probably like 5 feet wide. So it's a lot to go through. So I think that would be a really great resource.
Okay.
They're really focused on the energy code. They don't go much into Cal Green.
Right.
Yeah.
Okay. And then the next question is, Bruce also, kind of touched on that and followed up well. I mean, that's what, we're interested in. We have we're a pretty built out city. So, existing buildings are going to be a preliminary, our primary focus for us.
Yep.
And addressing those social equity concerns so that, those folks who can't afford to upgrade are not, footing the bill in their mixed use buildings.
Yes.
And many of those we know are, densely populated, based on sociocultural demographics. So I just want to know what kind of work is being done to address those concerns, whether it's through financial incentives, through public purpose funds and reallocating those, or how, I just want to get an understanding of the climate there.
Yeah, so a couple of things on that. One, there's more incentives that are happening. There are more programs that are focused solely on low income and ensuring that resources are directed there, and specific carve outs. I think there is a concern, and it's raised at the CEC and kind of held at the CUC or CEC, excuse me, that as we start this transition, the cost to maintain a gas infrastructure system is going to remain the same. And so with fewer people on that system, then their kind of cost burden can go up. So there's really a focus on how do we make sure this is happening in a way without overburdening folks who can't voluntarily make the transition. And so rebates and incentives are driven there. The other thing that is also happening is on the rate structure side. So currently there's a proceeding looking at all electric rate structures, because IOUs have been directed to develop those structures and understand how we can, again, or how can rate structures be developed that incentivize use during the solar peak period and discourage use during the 5 to 9 period, but not over discourage it. So things that can't be shifted, like cooking is really hard to shift. People don't get over penalized because of that.
Exactly.
So that is happening right now, and there's evaluations of those rate structures that are occurring. There's actually a workshop, is it this week? I think it might have been this week. Kind of discussing that, where a number of technical experts are at the table, as well as advocacy experts, right, like NRDC and folks like that, to make sure that things are being developed appropriately.
Okay.
So hopefully that helps.
That's one. Yeah, go ahead, Russ. But that's exactly what Bruce was talking about with the death spiral, and that's what I wanted to touch on. And there was the Agora Hills Climate Action Plan. When the city of Agora Hills council has discussed their climate action plan last week, and seeking approval to move forward with not implementation, but with coming up with adoption and such. And there were a couple concerns that shared by council members with regard to, if you're going to set a target, say for 2045 or something like that, and you're not close to meeting your reductions goals, is it fair for the city to go to the residents who are not decarbonized and say, thou shalt electrify now? And is that fair to do? And so it's a bit of it's the same kind of conversation. It's highly unlikely that will happen because of where the building codes are driving toward, but that was just another kind of piece of it. But sorry, Russ, go ahead.
Yeah,
we should probably go on, but yeah, I mean, there's certainly there's Peninsula Clean Energy and Marin Clean Energy are also offering rebates to people that can't afford to make some of these electrification measures happen. So there's some movement in that on that side, on the equity side.
Great, thank you.
Yep. I will say, yeah, and there's other pieces too, and Bruce threw in the chat there, SB 1477. So we're on the AEA is on that team of implementers for that program, which is including a number of different kind of pilots and efforts, particularly targeted at low income, from a number of different strategies, because I don't think there's kind of one avenue to get there. but also included in that are also financing models that are being undertaken. So we're looking at pilots for on-bill financing and things of that nature. So there's things that are kind of moving in this direction to figure out how do we address this. It also can be, we can say, like, there are folks who are kind of caught in the middle in terms of they don't qualify for low income, but they don't have expendable, you know, income, and that is a gap as well. We're right in the thick of it. I think there's lots of conversations that are happening and kind of raising this up where it needs to be in terms of the forefront. So I'm optimistic and confident that we will get there. And there's a number of folks at the table. Okay. And Sean still has to do his stuff. I'm going to go through this pretty quickly. This is just a little bit of eye candy-ish kind of work because I really like the conversation and the discussion. But just I want to say in terms of existing electrification, and Spencer, this goes to some of the costs in terms of it. I think one thing that's really important is to figure out, like, how do we do it? No, rarely is anybody can be like, okay, let me electrify my whole house all at once, and I can just do that capital investment. But more so on a phased approach. So if I'm getting PV for some reason, I'm going to make sure that my panel is sized for all of these additional loads that I'm showing here, right? From laundry to space conditioning to water heating, even if I don't have them, right? How can I kind of leverage that investment in that infrastructure upgrade to support these future end uses? So maybe, you know, it's only in year one I do the panel upgrade and water heating and PV. That seems to kind of work out based on incentives or based on my capacity or some combination of all the above. And it's not till year two I think about cooking or maybe an EV or space conditioning, or year three laundry, or some mixture of those, right? One of the things too, I think we're looking at for many of these kind of incentive programs, where we're looking at for the market transformation programs, how do we help solve some of the problems in terms of infrastructure costs, whether it's panel upgrades or smarter panel technologies, because that is a kind of a gap in some of our funding to how we get there. So I think our existing buildings are going to be the hardest to address just because of kind of initial capital costs. And so can we create models and approaches and support folks in doing this incrementally, where I'm making kind of a plan or kind of decision on initial infrastructure capital costs of my panel, and then I can go on down the line over time. And then I'm going to go through these case studies pretty quickly, because then it's 10:30 and we can have any kind of questions then. So this is a multifamily individual. It's actually located in Atascadero. It's two different buildings, 2 stories and 3 stories. They've got individual heat pumps on the roof and individual split system ducted split heat pumps. And it is designed to be all electric. They've got PV on the roof, which you can't see because of parapet walls. And over here, you can see they've got the PV carport. This is a central system. It's central domestic hot water. So one large central heat pump that's providing all the domestic hot water for all of the units in the building. That previous one was 60 units. This is 66. Here's my central system over here. It's a ganged sand-in heat pump system. There they all are on the wall. My cooking is only electric resistance. And in here we have ductless mini splits in each unit. So individual heating, central water heating. And last but not least, this is not a project I'm specifically familiar with, but I found this kind of case study book of net zero energy homes. So I put the link in here. But what I liked about this, it was a do-it-yourself, a DIY all electric retrofit. But what they did it in phases, just kind of I was suggesting before in terms of like, what do we do on the panel? Okay, let's do the kitchen, let's do this. And they just did things piece by piece as they could in terms of space, as they could in terms of finances, as they could, you know. So I just put that in there just as an example there. And they know we're at time. I can leave this conclusion up and then we can, I should turn it over to Sean to talk about some events, but just want to say Energy Codesa I mentioned earlier, switcheson.org is a consumer-facing website all on electrification hosted by the Building Decarbonization Coalition. So it's a great resource, one for you to learn about electric stuff, but also clients to say, hey, go check it out, see what's there. And Sean, can I hand it back to you? My sincere apologies.
Absolutely. Super great to see the conversation today. So since we're at time, why don't we just skip ahead a few slides, but let me pause on the Energy Code Connect slide. Yeah, so for anyone looking to learn a bit more about the Energy Code, we're offering more trainings, but just want to plug the Energy Code Coach. If you have more specific questions around electrification and the Energy Code, please leverage our service, Energy Code Coach. Our amazing staff like Amy, we have available to field your questions. You can submit a question online or over the phone. Just send us an email or check out our website. You can learn more, and we're happy to support you as you investigate a lot of the questions that I see in the chat today. So please do reach out to us. We are a resource for you, and we have some capacity to help as well. And then why don't we just move forward to the regional forum slide. Perfect. So we have a upcoming regional forum on Thursday, March 11th in the morning, and we're covering some more of these electrification issues. So our regional forums are an opportunity to investigate the Energy Code as well as policy issues in our region. So this time we're covering electrification. We're specifically looking at it, we'll start a little broadly, but we're looking at it through domestic hot water. And we see that as an opportunity where we can really get moving on electrification in our region. So we'll take a look at heat pump water heaters and also understand what the business potential is for installers, for designers, for contractors in our region to get moving on this and try to bring it down into terms, economic terms that we understand, and present a good business case for electrification as well. And Amy will be a part of that presentation as well. So if you're interested in hearing more of Amy's perspective or asking her more questions, she'll be one of our presenters. Perfect. And you can find more information on our website, on our events and training calendar. For today's event, if you requested learning units, I'll get those out to you. If you're not sure you provided your AIA or ICC number, just reach out to me. I think my email is on the slides that I'll share out as well. And then visit our website for more information. We want to be a resource for you for all these questions. So please do reach out. And then finally, I think we also had an all electric Z&E training last week covering a bit more about some of these appliances that were discussed today. So I might include that link to those slides and recording in the follow-up email too, since there was a lot of interest. That just looks a little more broadly at some of the small electric appliance and heat pumps for maybe more perspective for those of you that are interested. But with that, I do just want to ask if there are any more questions. We can stay on the line for a few more minutes and address those. And if not, thank you all for joining us. Really enjoyed the discussion this morning. And also thank you to Amy and Russell, our great instructors today. You did a great job answering the questions and covering a lot too.
This is Bruce. I had a question, and I saw Julie Clayton also had her hand up for some time now. I don't know if that's still intended to be a raised hand, but is there interest in the audience for me to do a 2-minute briefing on system optimization and cost optimization? And I'm not just talking about Mitsubishi equipment, I'm talking across the board. If people want to stay on, I'm happy to do a very quick hit, but it would give you a kind of a preview of what really should be covered in greater detail at a future date. Is there a show of hands, or
yeah,
should I go for it?
Go for it, Bruce.
Yeah,
okay.
And a reminder.
Yeah, so I just wrote some quick notes here. First of all, don't consider geothermal anywhere south of Montana to Maine and maybe through the Rockies. It's not cost effective. We have dual stage outdoor compressors, which we call cold climate compressors. which are much more cost effective and work down to minus 15 degrees. Really, they're rated down to like minus 13 or 15, but they actually work down to minus 30 in many instances. So they really work in every California climate zone, and anything that's marginal, I would just use them because they are significantly more efficient. Design away from doing a multi-head indoor, wall-mounted units with refrigerant lines all over the house. That's going to become less feasible when the 2023 CARB, restrictions on low GWP refrigerants come into town. There's going to be increased safety issues and diffusion requirements with those. It is way more cost effective to go with a central system. Contrary to what was said, the central box that looks like your average furnace but is actually a heat pump is about the same price or a little bit more expensive than the compact PEAD unit. It's that low profile air handler. That PEAD is a mid-static product that'll work with up to 40 or 50 feet of ducting. It can fit in conditioned space in the ceiling of a hallway. And it really makes sense with a short duct system like that to go to all metal and do mastic on all the joints and shoot for zero leakage and go for the low leakage compliance credit. It's not that hard to do. I've trained people that had no experience that did that fine the first time around. And it doesn't really make sense to go to low static unless you've got a really small ADU kind of application. Wall units work in a studio or a single room. Definitely avoid jumper ducts with a wall mounted unit in one room and some sort of heat transfer duct. That is a really inefficient scenario that has been done, and it's been scientifically proven to not be cost effective, doesn't produce good results, doesn't give you the comfort, takes a lot more energy. It's being hit in the code, and in this current cycle, you're not going to really be able to do that and get compliance credit for it. The 2022 code is going for half electrification right now, but independent analyses by BDC, Building Decarbonization Coalition, NRDC, they really believe it's going to push people 80% to full electric on the next code cycle. The 2025 code will definitely be all electric. So people should really start learning how to get there. The key thing is, if anybody isn't familiar with Rick Chitwood and his methodologies, he's kind of the energy guru for the CEC that retired recently, who is one of my mentors. So Chitwood, read up on Chitwood. His whole system is to downsize the equipment to about 1,000 square feet per ton instead of 400 square feet per ton. Maximize the return grill size, go for the MERV 13 filtration, but make the return grill huge so there's no static pressure losses. And then short duct everything, throw the air from the middle of the building to the outside, use bar type grills, have every duct go straight back to the supply plenum so you don't have Ys and branches, no trunk and branch design. Do bar type grills that minimize any kind of duct losses with no dampers at the grills. That's very important for static pressure. All the dampers go on the supply grill, which means you need, on the supply plenum, and that means you need access to that supply plenum. So if it's in a drop ceiling, have a removable hatch in the attic that you can take off with insulation on it, so you can make adjustments to those plenum dampers and get perfect balance throughout the house. That formula with R60 insulation in the attic, which only costs 50 cents more in new construction, greatly reduces the loads on the house. And deeply burying ducts in the attic, if you're in a retrofit situation, deeply bury all the ducts on the floor of the attic instead of the ceiling of the attic. That will cut your losses by like 60 to 70%. You can do much smaller systems, save on the system cost. So we make less money. What I'm telling you is not increasing our profit margins, but it's increasing our market because it makes this much more marketable. Deeply buried ducts in the attic on anything and as much as possible, throw the air from the middle of the house to the outside. The old adage of taking supply ducts to the outside edges of the house, that's like 1970s thinking. The same is true of putting all the ducts on the ceiling of the attic. That's where the highest temperature differentials are. You're going to have huge losses that way. Bury everything on the floor of the attic. And if you're concerned about serviceability, you can hang fluorescent flags from the ceiling so anybody going up there can see where the ducts are and they can access equipment. You can put signs hanging from the ceiling of the attic so you know where stuff is. Rake the insulation away. No bat insulation, everything deeply buried, blown insulation in the attic. R60, that's like 24 inches thick. And that just completely changes the equation.
Awesome. Thanks, Bruce. I think what I'm hearing kind of based on this is really it's an HVAC design approach or training that would be really valuable, which can go into more detail. We can also talk about kind of the requirements within the code that require a system to be actually designed and sized for the loads there. And so versus the like, how many fingers am I going to hold up and kind of, or my thumb or whatever I'm going to do to kind of estimate the size, right? That's not allowed anymore. So we're looking, and it hasn't been allowed. So we're looking at manual J for our load calcs, D for the duct design, S for the system sizing. You can look at ACA manual T for the register in terms of those optimized register designs that Bruce was talking about. So there's a lot more there that we can go into. And I think it's kind of a note in terms of conversation within 3C Red in terms of like, what additional trainings can be kind of built out to further support some of this industry, as well as what trainings may also be coming down the line for that as well through other applications. So folks understand the different specific applications of different technologies, whether it's kind of like the standard through the wall heat pump, kind of like your hotel system variety versus a mini split versus ducted mini split or ductless mini split. So I think there's what I'm not, again, my non-short answer is that we can look at more opportunities to provide deeper training, because this was a lot of content in a short amount of time and didn't have time to go deep into those, but kind of can set the framework to where we can go deeper into specific topics to build knowledge and capacity within our industry so folks can be successful.
In short, there's new school approaches to whole house HVAC integration for both existing buildings and new construction. And the code does not dictate those things, but they are more cost effective. So just following the code is not enough. You want to have the formula that makes it affordable to do this instead of gas in any situation. And that capability is there.
I would agree. Just overall, the code is not necessarily the code does not get into kind of optimized performance for any system, whether necessarily like water heating or space conditioning. It has some elements of it, but there's a number of different considerations as designers and installers that we need to be undertaking to really optimize the system. So it's 10:46. Thanks. There's still some folks who are hanging on there.
Thank you very much. I'm going to run. I put my phone number in the chat. If anybody wants to follow up with me, I can tell them a great deal about programs in the state as well, but don't call me till next week. I got a lot going on this week. Thanks very much. Okay.
Appreciate you sharing. All right. Any other final questions? We are 45 minutes over. Yeah, not quite. 15 minutes over. Hope you all enjoyed the conversation. Thank you for the questions, and feel free to follow up with Sean too. And we look forward to the next training.
Thank you so much, Amy, and thank you so much, Russell, and thanks everyone for joining.
Yes, thanks.
Hope to see you soon. Bye.
Take care.
Bye-bye.
Thank you.